Hello, this is our presentation of our unknown hormone project. We are the Mystery Molecules group, aka Cassidy Van Bibber, Chelsea Miller, Eileen Machuca, and Kate Mbacham. When we began, we first examined the possible list of hormones. We needed to narrow this list down to just one hormone at the end, so we did a little bit of research on what would happen if there were increased levels of these hormones. For example, if we had a high thyroid level in our experimental group, we knew thyroxine would be involved. Or, if there are major differences between these control and experimental glucose values, we knew alpha-glucocorticoid would be involved. Next, we looked at the data that we were given and saw that there were noticeable differences between the control and experimental values for body weight gain, thymus, tibia width, ovaries, uterus, pituitary, seminal vesicle, ventricular prostate, and the testes. From seeing these values, we were able to start eliminating some of the hormones from the list of possible hormones that was provided to us. We knew it wasn't thyroxine because there were no major differences in the thyroid. It wasn't alpha-glucocorticoid because there were no noticeable differences in the glucose. It wasn't ACTH because there were no noticeable difference in the adrenals. We also knew it wasn't somatostatin because we had an increase in growth, not a decrease. And we knew it wasn't epinephrine because there were no noticeable changes in the adrenals. We knew it wasn't testosterone because we had more of an increase in the female sex hormones than the male sex hormones. And we knew it wasn't the placebo because we had some of the changes in between some of the values. So to further look at this, we looked at the standard deviation tables.
Here we're looking at the narrowed down standard deviation tables comparing control and experimental data. The largest standard deviation appeared in the thymus, uterus, and tibia width. The deviations also noted in the ovaries. These results were important because they indicated where the experimental treatment had the most physiological impact. A high deviation in the thymus suggested a possible potential link to glucocorticoids since these hormones are known to influence thymus activity and size. But on the other hand, the variation in uterus, ovaries, and tibia width pointed more toward involvement of the ovarian hormones, particularly estrogen and progesterone, which are directly responsible for reproductive organ growth and bone density regulation. By focusing on the organs and tissues showed with the greatest differences, we were able to narrow down the possible hormones affecting the experimental group. Once the affected organs were identified, we compared and observed data and behavioral pattern to the known effects of the specific hormone. We focused on three possibilities of HCG, estradiol, and growth hormone. HCG can increase weight, food intake, and mammary gland enlargement. Estradiol, a type of estrogen, is associated with increase in mammary gland size, nesting, behaviors, defensiveness, and feeding, all behaviors observed in the experimental data. Growth hormone also increased mammary and organ size, but doesn't explain the behavioral changes as effectively. When reviewing all the physical and behavioral findings together, estradiol consistently matched the patterns seen in the experimental group. Therefore, based on the physiological and behavioral evidence, the hormone most likely responsible for these changes is estrogen. And from the glucose tolerance testing graph, we observed glucose spikes in both groups at the half-hour mark. The experimental group showed a slightly higher peak compared to control. Over the 3 hours, glucose levels in both groups gradually declined back toward baseline. These differences between the two groups were not statistically significant.
For our first test, we did a physical appearance and behavior assessment. For physical appearance, the control rats had a normal weight gain over time. Their hair and claws were normal and the mammary gland sizes were normal for their age range, while the experimental rats had over normal weight gain, increase in hair and claw growth, and increase in mammary gland size. For the behavior assessment, the control rats had general normal levels of activities, normal sleep to wake cycles, feeding activities and frequencies were normal, and their intraspecific interactions were normal. While the experimental rats had normal activity levels but spent more time nest building, They had a normal sleep-to-wake ratio and slightly elevated time spent feeding. Intraspecific interactions, they had a mild defensive behaviors at nest area. The main hormones that impacted the physical and behavior changes were estrogen, prolactin, progesterone, and growth hormone. For a second test, we did a radioimmunoassay for serum estradiol. The control rats had a 2,156 plus minus 334 CPM. The experimental rats had a 973 plus minus 531 CPM. Based on the results, there was a small amount of radioactivity counted in the experimental rats, which meant there was a large amount of estradiol in the experimental rats.
For our third test, we decided to do the pregnancy test in order to eliminate one of the two hormones, estradiol and HCG. In order to see which one was the unknown hormone, we needed to see if there was HCG present in the experimental rats, and the pregnancy test was the right test to tell us that. Because if the results were positive, it would have meant that the rats were given HCG, and if it was negative, it would have meant that they were not given the HCG. Therefore, because we got the negative test results for the pregnancy test, it meant that HCG was not the hormone given to the rats. After narrowing it down to the growth hormone, estradiol, and HCG, we eliminated the growth hormone after results of our first test. The physical appearance and the behavioral assessment shown that estradiol and HCG were more likely to be one of the unknown hormones, due to some of the behaviors of nesting as well as the increased size of mammary glands. Next, we decided to test for estradiol by doing the radioimmunoassay test for serum estradiol, which came up with high levels in the blood, indicating that was the possible hormone given to the experimental rats. Finally, we decided to eliminate HCG after the pregnancy test, which came back negative, confirming that HCG was not the hormone given to the rats, as it was not present in them. After eliminating the HCG and growth hormone, we conclude that the hormone given was estradiol. Thank you so much for watching.